I'm also happy to introduce the third speaker, Dr. Yousif Albastaki. He's the chairperson of MIS at Ahlia University. His session will be about robotics with odor sensing capability. This is really, really interesting and exciting. Dr. Yousif worked as an IT advisor at the Deputy Prime Minister Office at the Kingdom of Bahrain and previously worked as the Dean of College of IT at the University of Bahrain, Dean of Admission and Registration at the University of Bahrain, and as a Vice President for IT Services and Finance, again at the University of Bahrain. Currently, he is an Associate Professor at Ahlia University. His research interests are neural networks, genetic algorithms, machine learning, and e-government strategies and implementation. Welcome, Dr. Yousif. A pleasure to have you here with us today.
Thank you, Doctor. So let me just share my screen first of all. Good morning, everyone. I'm really honored and I have all the pleasure to be part of this issue. I have a very good history with Bahrain Polytechnic, the first Bahrain Polytechnic, where I was a student and always was an honor to be a student during that time. Good morning, everyone. My topic is about integrating smell sense in robots using artificial neural networks and machine learning techniques. I always look at this verse in the Holy Quran, and I can read it in English. It says that, and as the caravan set out from Egypt, their father, Jacob, said in Canaan, indeed, I smell the fragrance of Joseph. So in this verse of the Holy Quran, we are talking about the smell. The question raises here, can we transmit smell? Can we transmit odor? So this is what we are trying to answer in this session and during the coming few minutes we have. If we look at the 5 senses we have, okay, touch, hearing, taste, smell, sight, and we'll try to align that with robotics. There are a lot of research where touching issues in robots has been successful. Robots can see, robots can hear as well. There are 2 areas which we need to investigate more. One is the capability of smell in robots. The other one is the taste. Capability in smelling capability in robots, we talk about something called electronic nose, and this is what we'll be focusing on. The capability of taste, we call it electronic tongues, which is beyond this research. Now the question will be, can we have robots which can smell? Okay, can we have robots with the capability of smelling? This is what we'll be talking about. I'm part of an eNose research group in Ahlia where we focus on applications more than design. Okay, we focus on application. We have been working on this. We started this group in University of Bahrain. Then through my shift to Ahlia, we have shifted the group to Ahlia as well. Let's have a quick look at the human olfaction system, meaning how the human being smells. Scientists, they say, at the back of the head of any human being, there's a database for odors. So whenever a human smells anything, for example, if I smell a flower, data will be retrieved from this database, if we might say, and a human being will recognize that this is a flower. If you, for example, smell an apple, the same thing will happen, a berry, a perfume. What will happen if we smell something new, the first time to smell this subject or odor, if I might say? What happens, the human being will start asking the question, what is this? Then we'll answer that this is a specific subject, object, whatever it is. Automatically, this will be stored in the database. In the future, if the human smells the same object or subject, we'll know by retrieving the data from the database in back of his head, and he knows what is this specific subject. What we are trying to do is to mimic this operation, a human olfaction, and transfer it to machines. We try to copy this process and see how we can do that, okay? So aim is to integrate an electronic nose. So designing an electronic nose into robots to have the capability of a smell. This is the aim. And I have to say that these type of researches, although there are some breakthroughs, still it is in the early stages. The idea, the basic work we did a few years back was artificial neural network-based ENOS concept. We tried to use backpropagation algorithm in artificial neural using sensor arrays like this, okay? Taking the data, feeding it to artificial neural network backpropagation, and try to have a machine which recognizes these type of odors. To a certain extent, we succeeded, actually. We used the backpropagation, and we got a good result in that as well. The result was very promising. Nowadays, with the advancement, but this procedure, the difficulty was that we needed to do a lot of coding and a lot of complicated issues. With the advancement, we have an artificial intelligence and a new machine learning techniques. We'll try to replace the backpropagation algorithm with some simple machine learning algorithms. We'll try to do this. And this is what we did actually. So the idea of ENOS, it's a device intended to detect odors or flavors. So this is, in a simple word, what do we mean by ENOS? An ENOS is a device that identifies a specific component of an odor and analyzes its chemical makeup to identify it, to see what is it. Basic design is to have different vapors or chemicals, feed it to a sensor, and the result will be taken and feed to some algorithms. And this specific experiment, we are using the k-means clustering algorithm to see if we can cluster, okay, or classify odors. Classifying it means that differentiation. Differentiation means that we can identify odors. So that's why we are using this simple k-means algorithm to see the capability or the possibility of classifying odor. What we did in this experiment, we have taken 3 different subjects: coffee, some muscular cream, and whiteboard pen. The reason we use these subjects because they have strong odor, they have strong smells. And we collected a lot of data, large sample of data of these 3 subjects using these type of odor sensors. These are sensors, okay, quite old sensors. It's nearly 12 years or more than that we used these sensors, although there are the new ones, but still the capability to a certain extent is limited. So we have collected all sorts of the odors of these subjects, okay? These are the samples we collected. Actually, I've collected nearly 6,000 samples of each of these subjects, purified it and analyzed it. In this experiment, I used R. R is the previous speaker, he talked a little bit about R. R is a free software, it's an open source. It has a lot of capabilities. With the R Studio, I used it for analytical purposes, just to identify these odors. Although we can use Python as well, or we can use some other artificial intelligence packages as well. R is, for me, is very suitable for analytical purposes. If we look at this simple chart in front of us, this is a time-based odor classification and strength for every single component: the coffee, okay, the muscular cream, and the pen. It's shown in this diagram. We collected them. Then what we did, after having a number of visualizations and looking at the different samples, for example, this is the muscle cream sample 1, this is muscle cream sample 2, and this is the classifying of these creams. Again, we used R for looking at these data. What we did, we had to go through the data purification and normalization. This is the result for each subject we had. We looked at it differently now. We fed it to the k-means algorithm. The problem with k-means algorithm most of the time is to identify the k value. We use a number of other algorithms to propose the k value. K means how many group of data are there or how many clusters of data are there. Some of the algorithms propose that we should use 4. So we used 4, but we noticed when we use 4, there are some overlapping. Overlapping means the machine is confused, doesn't know which odor is this. So it might overlap with them, be confused to a certain extent, not knowing what odor is this. We tried another algorithm, again, to propose 4. Again, we found that there are some sort of overlapping here. So this machine will be confused, doesn't, or it cannot recognize what type of odors are there. The reality that we have a 3 subject, we tested for the value of K3 and it gives us a perfect result. It says that you have 3 clusters or 3 groups of odors. So this indicates that we can classify odor. We can collect odor and we can classify it. So once we classify it, we can identify it, we can differentiate, we can say this is odor number 1, odor number 2, odor number 3. So I can claim to a certain extent, and I'm very reserved in saying this, okay, that yes, we can transmit odor. We can transmit odor. We have done some experiments and we managed to transmit odor. So once we know that we can transmit odor and we can classify it, why we need to do these type of things? Why we are doing this? Before jumping to what I'm saying, I just want to say one of the first presenter today, he was working with the facial and RFID. Actually, we worked with body odors as an authentication for people. Body odors, a human body, okay, emits some sort of odors. During this odor, we can recognize the person who was at that specific area, or we can give him authentication and things like that. Additionally, we can use it in airports, for example, instead of using dogs for detecting drugs and things like that. Okay, the problem with the dogs is that training dogs are very expensive and the lifespan of dogs is short. So if we can manage designing these type of noses, put them in robots, robotics can detect drug smuggling, explosive, a lot of things can be done during this type of identification. For me, I will focus, if you give me a few more minutes, I'll focus in this, which I really find very interesting. Using eNose or using robotics with the capability of a small smell in diagnosing diseases. In the Middle Ages, if we see, doctors used to take blood samples. They either smell it or look at it and even test it just to decide what type of disease that specific person has or shows. So if we look at the human breath, what we are trying to do in this type of research, usually there are 2,500 different chemicals in the human breath. Scientists showed that 2,500 different chemicals in our breath. Can we take this breath and analyze it and accordingly decide that specific person might have this specific disease or might in the future will have these type of diseases? So this is the idea of having robots with the capability of eNose. In the United States and Europe, a lot of studies are taking place in creating a national breath sample databases. They take all sorts of sick people, like cancer, people with cancer, they take breath samples and they store it in databases. In the future, when we have a new patient, when we have an ordinary person who goes through normal checks, we can take a sample breath and compare it with the breath which are stored in the databases and try to diagnose what type of diseases those people might have, okay, or might get in the future. So these are one of the applications which talk about. Additionally, we have people with anosmia, people who cannot smell. Can we provide them with these devices which helps them, especially when there's a gas leak, when there are fire, when there are food spoilage? So we can do that as well. Future cars, one of the speakers were talking, can we have cars with the capability of smells? Mobile phones, can we include the capability of smells in mobile phones? In our research, in 2004, we published a number of papers where we managed to classify different type of perfumes and distinguish about them. Recently, we published two books, edited two books. One is Electronic Nose Technologies and Advancement in Machine Olfaction, which was well received. Another book we just recently published, Implementing Computational Intelligence Technologies for Security System Design. We did a lot of research in food spoilage. Actually, this is done with one of my students. We use different type of meats, chicken, to see can we, because what happens in factories, people usually smell, human being smells if the food is spoiled or not. So we use these type of technologies and we got good results actually in this. Another research we did in multimedia. Multimedia today, we have images, we have video, we have voice, we have audio, voice, all these things. Can we include one more element to multimedia, which is the smell? Okay, we published a paper on this a few years back. So this is one of the questions which we are investigating. We are saying, okay, now you can see a photo, you can see foods, you can see it through a video, you can hear people explain it. Can you smell it? Can we add this capability to it? So these are some of the researches which we published a few years ago in this research area. Currently, we are doing a lot of works, okay, especially trying to define a framework for artificial neural network-based computerized nose for clinical diagnosis. A lot of research is going on that framework for artificial neural-based odor sensing systems, writing another or editing another book, looking at the humanoid robots with odor sensing capabilities. What I did in this paper, I tried to briefly describe our experiment without much of technicality. I avoid technical issues as much as I can. Conclusion says that this type of research is promising. Actually, for just a cement, recently they produced an electronic nose with the capability of diagnosing one type of cancer. It was very interesting to see that. We are working in having a general electronic nose. There are a lot of products where you can identify one type of smell, specially designed devices or electronic nose, and even robots with the capability of defining one type of gas, one type of smell, where we are trying to have a robot with the general capability of smelling or mimicking the olfaction system of a human being and robots. Thank you very much for your kind attention. I tried my best to convey the message to everyone. If anyone has any sort of question, I'll be very happy to answer. Thank you very much.
Thank you, Dr. Yousif. That was an extraordinary presentation. I enjoyed it very much. And any participants can type their questions in the Q&A box, and I will gladly pass them to Dr. Yousif. Dr. Yousif, I mean, this is really nice idea, and there are so many applications. I remember from a trip in China, I found out that Shenzhen has a smart city infrastructure, and they actually use this technology in the trash bins. So when they detect the bad odor, it's time for the trash bin to be collected and cleaned. So there are so many applications, and it's not a usual subject, but I think it's gaining attention now. Okay, so we have the first question. Did you consider the capabilities of dogs, you mentioned that already, as well in your research, as they have the best noses, as per my knowledge, by Kai Mythic?
Yes, absolutely. Dogs are one of the animals which are used heavily in this type of research. As I said, at the moment, research says that dogs can smell better than human beings in millions of times. Okay, still a lot of researchers are investigating that. But dogs, as I said, in our research, when we look at dogs, sometimes they get fatigue. They cannot smell properly. Sometimes they get sick. And the lifespan of dogs is very short, provided that we spend a huge amount of money in training the dog. Okay. So scientists are looking for replacement. This is the main theme or the idea of this type of research.
Exactly. Another question by Engineering Herbert, one of our presenters. Very interesting AI technology, Dr. Yousif. Can the technology be used to detect dangerous gases or fumes?
Definitely. It is. There are plenty of odor sensing small devices where it uses for detecting explosive, gas leaks. In addition to what he was doing in his research and his presentation, I wanted to comment, but I couldn't. The idea of human body odors and authentication. In addition to facial, this is one of the biometrics which we did some experiment. We collected some body odors and we tried to classify it. To be honest, to a certain extent, we couldn't because the sensors we have are not very accurate. But I think in the future, we might have that, okay? For security reasons, for crime detections, a lot of things. Can I say that this particular person passed in that specific area during that time through collecting the odor in that specific? We know that we have security cameras nowadays, but people will cover their faces with the work when they want to commit a crime or anything. Can we detect the odor? So this is one of the research which is going on, and we hope that there'll be some breakthrough when it comes in the advancement we are seeing in technologies.
Thank you, Dr. Yousif. Another question from Kai again. I recall the emission on landfills which sometimes produce toxic gases with little smell but cause havoc to human life. Is that a field to look into?
Yes, I can say that there are two, there are research we are trying to combine image processing with the odor or odor detection to detect a specific type of gases. Sometimes you have a gas which has no smell or the smell is very little. So you can use it with the image processing issues to identify, because some gases, they have colors and, without smell. So there are research going on in these type of things. There are research going on to identify using two type of technologies, image processing and smell detection, and identifying fields where they grow drugs, okay, different type of drugs. So they send a drone, collects some odor and collects images, analytic, to decide if this specific field is any sort of drug, or even they plan for explosive and things like that as well.
Okay. And another question. Oh, it's Kai again. He wants to get in touch with you. He's into waste management, so he's passing his contact details.
Be happy to meet him and talk to him.
Kai, please pass the contact details to the organizers, who will pass them to Dr. Yousif to avoid access of your personal data, your email and your phone through the chat. And Dr. Yousif, what will happen if the number of odors that you're trying to classify increase to a large set? How do you feel this challenge? Yeah.
This always depends on the capability of storage. We are talking nowadays about cloud computing. We are talking about massive storage. So it depends on the storage most of the time. Actually, the more data we collect, more accuracy we get in this type of research. So that's why sometimes I classify it under the big data analytics processes and Internet of Things, because it's totally depends on sensors, collecting data from sensors.
Exactly. Yes, that's really interesting. Dr. Pradeep, also another of our presenters, says it's been a good era. And he asks, what is the ENO sensor capacity?
The biggest problem we are facing at the moment is the accuracy of sensors. Yeah. Okay. Sensors there are a lot of studies going. Actually, we tried to assemble some of the sensors, buying small sensors and putting them together ourselves with the College of Engineering. Unfortunately, we couldn't achieve much on that. Still, we are waiting for a breakthrough. Nowadays, there are big sensors. Honestly, a sensor as big as a table, which collects odors for explosive detection and things like that. But hopefully in the future, if scientists and researchers manage to decrease the size of these sensors with more accuracy, we can integrate them into robots, we can integrate them into small devices, and we can use them in different places. So this is a very promising research area where a lot of people are working, and a lot of researchers around the world are doing a lot of investigation in this type of odor detection research.
So thank you very much, Dr. Yousif. I think audience really enjoyed and made the most of your presentation. I think it was one of the best presentations of the conference. So thank you very much for your time and for your input. And please stay with us for the final presentation.
Thank you. Great pleasure. Great pleasure. Thank you very much. Thank you.